Hi, here we have a caravan battery charger. Now it's pretty much a switch mode power supply. I volunteer at the local repair cafe where people bring items in to repair, and the organiser brought this in and asked if I could have a look at it. Now unfortunately we didn't have a lot of time on the day when he brought it in, so I said, well look, I'll take it home and I'll get it on the bench and we'll have a look at it. It's just dead, there's no output, so I've already checked that the capacitors are discharged, because I know somebody mentioned something like that in the inverter video. So we'll pull the board out and we'll start having a look to see if we can find out what the problem is. Right, let's see if we can get it a bit there, we can see what's going on. So, I don't know if you know how a switch mode power supply works or not, but what we've got, the mains comes in here, it goes through a fuse, through a little bit of filtering, and then we've got a bridge rectifier here. Now on this particular one, we've got two capacitors, which are linked across the bottom. So the mains voltage comes in on this side and on that side, and we've got a tap in the middle here. So we've got, so when they use that as ground, we've got a positive voltage and a negative voltage on each of these capacitors. That then, so when you use that as ground, let's say, there might be 120 volts here and minus 120 volts across from there to there. This then comes down to these MOSFETs. Now the MOSFETs, the output of the MOSFET comes down here. I'm just thinking where we are. Yeah, it comes to here, goes through a capacitor, and then to this transformer here. And there's a couple of lines come off here. It goes through a small transformer, which is here, and a couple of lines come off to this chip here. And what that does, it oscillates basically positive, negative. That then steps up the frequency of DC from the mains. So basically mains comes in, gets rectified to DC through these capacitors, and then gets switched at a higher frequency back to AC again through this transformer. It then gets rectified and you're supposed to get 12 volts out. Now the reason why they do this instead of just using a big transformer is there's a few reasons. One of them is efficiency. The switch mode power supplies are more efficient than the linear ones. They're cheaper to manufacture because you don't need as much metal, you don't need a massive transformer. Because of the higher frequency you can use a smaller transformer and there's not as much metal in them, so they're lighter and more compact. There's a couple of disadvantages with them though. The disadvantages are sometimes they produce a fair bit of noise, so if you wanted to use one for, let's say, a ham radio, sometimes you're best off using a linear power supply which doesn't have the noise that the switch mode one does. So that's roughly a little bit of an explanation of how they work. So I think the first thing we'll do, we'll check the fuse, because we've had a few repairs lately where fuses have been gone. So I'll just put the meter in continuity there and we'll check that. Yep, so the fuse is intact, which is a good sign. Right, let's flip this over. Obviously exercise extreme caution when working on things that may have high voltages. So we'll just put this on volts DC and we'll just see if there's anything in these capacitors, which there shouldn't be because I'd already checked them earlier. One thing these capacitors have got, if you notice, there's a couple of resistors just here and here. They're called bleeder resistors, and what they do is after the power is being disconnected, the capacitors then discharge through those two resistors, and there's the capacitor there and the resistors across there, and there's another resistor from there to there. So they're wired in parallel with the capacitors, and they slowly discharge the power out the capacitors, so if you then touch the board you don't get a shock. Right, so we'll check the bridge rectifier next, which should be okay because the fuse would have blown otherwise. Let's put in the diode, and yep, so that's okay. Yeah, and then if we go from, yeah, we'll just check there's no short on there. on the input. Right, so we know we'll just check continuity from here to the bridge rectifier, which is okay there, and okay there. So the power's coming in, it's getting to the bridge rectifier, it's then going through the bridge rectifier, we know that's okay, and charging the capacitors up. It then comes to the two MOSFETs here, so we'll just we'll check those just to see if they're shorted out. Now, we are getting a short reading across there and there, but that is probably due to them being connected to a coil. I mean, it might be worth taking them out just to double check. Yeah, I think we'll do that. I think we'll pull these MOSFETs out, we'll just double check that they're okay. Because like I say, when you measure, sometimes when you measure things in circuits, you're actually measuring other components. So I shall just heat the iron up and we'll whip those out. Let's get some solder braid. Like I say, these usually fail quite spectacularly, and when they go, it would normally take out the bridge rectifier, the fuse, and a few other parts as well. So, right, we'll just clean up these pads now with the solder wick. Right, I think that'll do. So we'll check these now. Looks like we might have a short on that one after all. That's weird, unless we're just triggering them. Because for a moment there I got a reading that was okay. Yeah, the reading's measuring okay there now. And now it's not. Tell you what, I'll try these on the component tester. Yeah, seems alright that. I'll double check this one. Yeah. So they're measuring okay with the component tester. I don't think that's the problem. Right, so where do we go next then? So the power comes in, it gets switched by these. Let's just where's my meter lead gone? So the gate goes here, and we've got two links which just go straight across. So the gate goes to here, to this coil. That's the input of that coil. Now there's a coil on the other side there which is like a triggering sort of coil, this TX1. that should go to the other gate, I think. Hold on. No, that one's the power. That one should go to the gate, which it does. Right. Yeah, because one's positive and one's the opposite way around for the negative here. And then this coil is driven by, so it goes down there to that pin of the chip. That's one of them. And the other side of that coil goes up here through that leg and ends up here on that chip. And apparently what happened with this was somebody plugged it into a generator and it stopped working. So I don't know what could have gone in it. What's this chip here? It is a SG 3525A. Right, I'll go and see if I can pull up a data sheet for that. But in the meantime, we'll just check some of these other components. We've got a few diodes here on the top, so I'll just check those. That one's okay. That's okay. That's okay. That's okay. That's okay. Another diode here. That's okay. Another one over here. So I think that's pretty much all the diodes on this. All the diodes look alright. What happens on this side of the transformer? We've got a rectifier diode. There's like a high-speed rectifier diode, and that rectifies the high-frequency AC that's now being generated from this side of the circuit back into DC. It then goes through a bit filter in here, through this inductor and to this capacitor, which is on the output. And there's also a little bit extra circuitry here, and what that's for, that'll be to set the voltage. So when the voltage gets to a certain level, it lights the like the LED up in this opto isolator, which will then tell the chip here to stop oscillating as fast, so it kind of regulates itself, because otherwise, you know, the voltage just keep rising. So that's how the power supply regulates itself. So let's just check this output diode. Well, doesn't look like there's any shorts there. That's just the capacitors charging and discharging. Yeah, so yeah, they're normally sort of, I think they're called shocky diodes, or shock, however you pronounce it, and they've normally got a low voltage drop like that. So, and there'll be two in that little package there. So yeah, I'd say that's fine. What else have we got on here then? We've got a 1, 2, 3. We've got about 5 transistors there. We can check those. Yeah, that one's okay. There's one over here. Yeah, looks okay. Doesn't look like we've got any shorts. Yeah. Another one here. Yeah, that seems fine. I've got another 2 down there, so I'll check those ones. Are they here? No, I don't seem to be getting a reading on there. Unless it's a different pin out on this one. Yeah, that's okay. And where's the other transistor? Up here. Right, so those check out okay. Right, I'm going to give this a bit of a clean up. I think we'll put those two MOSFETs back in. And I think we'll power it up and we'll check some voltages. Let's get a bit IP on these. Right, I'll get that back in. I'll try it out. Next one back in. Let's see the other one back in. Right, we'll solder those back up. Yeah, quite common failure on these is the MOSFETs blow, and it usually takes out the controller chip as well, and sometimes the bridge rectifier. Yeah, so things to check. Obviously, if the fuse is gone, is to first check the bridge rectifier, then check the MOSFETs, and then the controller. Now we'll put some power onto this. I'll just hook some power up to it, so bear with me 2 minutes. Right, I have wires suitably poked into a kettle lead there, or a Euro lead, which is probably not ideal, but I haven't got a safe block, so like I say, don't copy what I do, because it may not be safe. Right, we have power on. So the first thing we'll do, we'll just check what voltage we've got on these capacitors here, and what we've got on the bridge rectifier. So 341 volts there. And across this capacitor, I have, well, if you use the centre as the ground there, we've got 190 volts that way, and 150 volts that way. Let's see what we've got on the output. Nothing. So it's like this circuit isn't oscillating. I think there's a capacitor here which is the supply for this IC here, which is the oscillation chip. And if we get them on the right way. So I've got 12 volt supply going to that chip there on those pins. On that pin there and that pin there by the look of it. That looks ground and that looks power. So I think what we'll do is we'll get the data sheet up for this IC. And we'll see what voltages we're supposed to have. I'll just switch this off there a sec. And we can actually measure the capacitor's discharge in here. And as you can see, they discharge quite rapidly. That's because of that bleed resistor that I mentioned earlier. You still see, take 30 seconds or something for it to be fully discharged. Right, I'll go and see if I can find a data sheet for that chip, and I'll be back. Right, so I've got the pin out of the chip. So what we'll do, we'll put the power back on again. I'll put the pin out of the chip in the top corner of the screen, and we'll see what voltage we get. Right, so we know this is the ground here, and the top pin is supposed to be, which is pin, this top pin here is supposed to be 5.1 volt reference, and we don't have anything on there. The next one down is VCC, which we've got 12 volts there, and then output B, which it is because it goes up there, and then obviously the little transformer. The next one is VC. 1, 2, 3, hang on. Which we have 12 volts on there as well. The following one is ground, which it is. Then we've got another output pin, which doesn't have anything on it. That one is shut down, which is just wired to ground if it's not used, which tells the chip to activate. And then we've got compensation, which just runs through a capacitor and a resistor, which goes over to the feedback circuit over here. So we haven't got the 5.1 volts on the voltage ref, which is internal to the chip. So I'm just wondering if this IC is blown. The rest of the pins over here, there's a couple of them not used, which is those ones there, because it's only a single-sided board. Inverting and non-inverting inputs, which are for the feedback loop. And the only other one is a soft start pin at the bottom here, which I think just goes through a capacitor to ground as well. So there's either something pulling the 5 volt supply down, or the 5 volt reference voltage down on this chip, or the chip is damaged. I'll just see what these capacitors are doing, because I don't want to get zapped. I'll just wait for those to discharge a little bit. So my thinking is there's either going to be a short between ground and this pin here somewhere, or this chip's fried. And I'm kind of leaning towards the second one. Yeah, it's safe to sort of work on that now. Let's just see what the resistance is between ground and that pin. Yeah, we've got K ohms there, that should be fine. So I think this chip's fried. That's what I think. I'll disconnect it from the mains, and I think we'll pull this chip out. Oh, one side done. Right, so we shall put a cross on that, and I'll see if I've got one of those.
A few moments later.
Right, I am back, and I do happen to have a replacement chip. Right, so we'll pop this in. Obviously make sure we're putting it in the right way, and then we'll solder these back up. Right, I shall give this a little bit of a clean up. Right, I'll get this old chip out of the way, and we shall connect the power back up. Right, so now it's either going to go bang or hopefully work. Well, it didn't go bang. Aha. That's it, look, we've got 13.78. on the output there. And we'll just check what we've got on that VREF pin now, which is just here, 5.1 volts. So yeah, it was that chip that had failed, and the rest of it's working fine. So yeah, I'd be well happy with that then. That's it, I'll get my wires on the right way. Yeah, I'd be well happy with that then, because I think he said they were about £100 for a replacement one of these. And I think one of those chips, was about £2.50 or so. So yeah, right then, I think we'll call it a wrap on this one then. Well, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comments section below. And as always, have a great day. Thanks for watching.